Hello, this is Sriman and welcome to Genius Mathematics. In this video, we will see about rational numbers. First, we will see definition, then what is terminating and recurring. These words will be very helpful in differentiating rational and irrational numbers, and this very interesting equation we will solve and some examples we will get through. So first, the definition of rational numbers. All numbers that can be represented by P by Q form where Q is not equal to 0. If Q is 0, then it is clearly infinite, gives infinity. And also P and Q must be integers. So that is another thing with rational numbers. So any number that can be denoted in P by Q form where Q is not equal to 0 and P and Q are integers. So that's the definition of rational numbers. Now some examples can be 4 by 5, 7 by minus 2, 4 by 1, 4 by 1 and let's say 0, it is also a rational number because it can be denoted as 0 by 1. So all these are examples of rational numbers. Now the next thing we will see is terminating and recurring. So what are these words when it comes to rational numbers? Now, what terminating means, it means to stop. So let's say we have a number, let's say we have decimals like 0.125. This is terminating because it just stops with 0.125. It does not go like, let's say we have 0.11111. This is not terminating because it just goes on. So we will write this term as 0.1 bar. So this is how we will write. So this is non-terminating and this is terminating. So that is the meaning of terminating. Now the next thing is recurring. Now what is the meaning of this word recurring? Now again, the meaning of recurring is repeating. Let's say we have again 0.11111. It goes on. This is recurring. Now let's say we have 0.1254243 and something like that. So this is actually non-recurring because it does not repeat any sequence. But this repeats sequence. For example, let's say we have 0.242424 and it goes on like that. This is again recurring. But this is not recurring because it does not have any specific sequence to this. So that is the meaning of terminating and recurring. Now we will combine these two and we will separate rational and irrational numbers. So I will write terminating with T and recurring as R. So T and R. Let's just have a tabular column like this. So we have 3 categories or maybe 4 categories, but the fourth one is not that relevant. Let's say we have a number that is T and R, that is both terminating and recurring. For that we have example like 0.11 and it stops there. So this is terminating because it stops, and it is recurring 0.11. So 1 repeats. But this is not that officially true that 0.11 is repeating. So terminating and recurring form, this is not actually a true form, but all these other forms will be very helpful. So the next thing is terminating and non-recurring. So it must stop, but it should not be recurring. So again we have the same, again let's take another example like 0.124. This is terminating, it stops, and it is non-recurring, does not have any repetition. So that is the thing with terminating and non-recurring. Now let's get to recurring. Okay, let's first write terminating. So we have non-terminating and recurring. So it does not stop, but it repeats. For example, let's take 0.363636 and it goes on. This is not terminating because it does not have any full stop at the end or any other specific numbers at the end, and it is recurring because it repeats. So this is non-terminating and recurring. Now the last thing is non-terminating and non-recurring. So this is a very special form. Let's take pi as an example. pi is 3.1415 and it goes on. It does not repeat any sequence and it also does not end. So this is non-terminating and non-recurring. But what are all these forms comes under rational numbers and what are all these forms comes under irrational numbers? The thing is, all the terminating and non-recurring and non-terminating and recurring, these two forms can be denoted as rational numbers. Again, rational numbers is denoted by the letter Q. So both these forms can be written as rational numbers. And again, this is also rational number, but this is just simpler form. So all these three forms can be represented in rational forms. But this is irrational number, because all the three forms here can be represented as we saw in definition in a P by Q form, where P and Q are integers. But here it is irrational numbers because it cannot be represented in a P by Q form. So that is the reason all these three are rational numbers and this form here is irrational number. So that is the thing with rational and irrational numbers. Now let's solve the interesting problem we have here. So the question is 0.99999 and it goes on till infinity equals 1. How do we prove this? Is this true? There can be one argument that, let's say we have 1 and 2. Is there any number between 1 and 2? Yes. There are infinite numbers like 1.5, 1.6 and something. But is there any number between 0.9999 and goes to infinity and 1? There is no number between these two numbers. So these two numbers must be the same. That is one argument. But here I am going to prove why these two are indeed equal. The thing is, let's take this number and we will get from here to 1. So let's take x equals 0.99999. So this is non-terminating and recurring, which means this can be written in a rational number. This can be written as rational number. So this is a rational number. We know that from what we have seen before. So this is non-terminating and recurring, which means it must be written in form of rational number. So the value we need is x. So now let's multiply x with 10. That is, multiply this equation with 10. So we get 10x equals, so this decimal will come here. So we have 9.99999 and it goes to infinity. Now subtract these two equations. We have 10x minus x equals 9 and it goes on minus 0.999 and it goes on. These two non-terminating forms are equal because these two goes to infinity. So the numbers after decimal are the same. So we have from the left hand side we have 9x equals 9 minus 0, which gives 9. So x equals 1. But we have given x as 0.9999. But the answer we got is x equals 1. So this proves that x equals 0.999 equals 1. So this statement is actually true. So this is one thing which you can solve by just looking at non-terminating and recurring forms. This can also be proved by another method. Let's take, so the other method is somewhat simpler. That is, the value for 1 by 9 is 0.11111 and goes to infinity. For 2 by 9 it is 0.22222. For 3 by 9 it is again 0.33333. So if we follow the same pattern, 9 by 9 must be 0.99999. But we know 9 by 9 equals 1. So 0.99999 and it goes on to infinity equals 1. This is another kind of proof for this. So this is about the interesting equation. Now the examples I am going to show is how we can convert decimals into rational forms. we can easily convert rational numbers into decimals. Just division. Let's say we have 2 by 3. We can just convert this by just normal division. So this gives 0.66666 and goes on. So we will write this as 0.67. So this decimal can be written as rational number, which means this is a rational number. But what if we have given the decimals and we need to convert it into rational numbers? That is in the opposite direction. That is what we are going to find now. So again, we can take this is a decimal and we are converted into a rational number. So that is the method we are going to use in all these. Let's take, we have example like 1.27 bar. So we are going to find this into, we are going to convert this into a rational number. Again, we know this is recurring. What is the meaning of this bar is this, so the number below the bar must be repeating 1. So in this equation 7 is recurring. So it is recurring and it is non-terminating. So this comes under rational numbers. So we are going to convert this into rational numbers. Now x equals 1.27 bar. So if we find the value of x, that is the value of 1.27 bar. Now let's multiply this with 10. We get 12.7 bar. So this is clear. Just taking this decimal to the other side. So x equals 1.27 bar. 10x equals 12.7 bar. So the idea for this is we just need to get the numbers after the decimals same. That is the progressing or the recurring numbers. So again, multiplying this with 10, we get 100x equals 127.7 bar. Again, just taking this point one more time. So let me just write this as this. So just keeping this decimal here, since we are multiplying by 10. So then what we should do is subtract these two. So we get 100x minus 10x gives 90x. 127.7 bar minus 12.7 bar, which is 127.7 bar, 12.7 bar. These two cancels because it is infinity, because it tends to infinity. From here we get 1. So 115. So this is the answer we got from here. Now x equals 115 divided by 90. So this is the answer. So the value we have is x equals 1.27 bar and the value we got is x equals 115 by 90. Again we can divide both these by 5. So we have 23 by 80. So this is the final answer. We have converted this decimal, that is non-terminating and recurring decimal, into a rational number. So this is the value for this. So let's now take another example that is terminating. Again, terminating decimals are easier because let's say we have 0.16 as this is terminating and non-recurring, which means this is also can be converted as rational number. So how can we write this? We can just do 0.16 into 100 divided by 100. So this decimal comes here. So we have 16 by 100. So we have converted this terminating and non-recurring decimal into a rational number. Again, it is important to get the fraction in its lowest form. So if we do that, dividing by 4, we have 4 by 25. So this is the answer for this. So that's all about rational numbers, terminating, non-recurring, and how to convert decimals into rational numbers. Thank you.